Hello. Welcome to the fifth lecture of this entire series. In this lecture, we will be working around with descriptive statistics, but we'll be understanding will not work with Python as of now. So in this lecture, I'll first explain you what dataset we are going to use and what is the case study that we are going to use to understand the concepts, and then we'll actually move on and then we'll understand what all is there, to learn. So let's just dive into it. Let's just see the screen. We have, the case study is related when you are in your 7th grade, and in your 7th grade you gave the exam of mathematics, and you had 30 students in your class. So these are the marks of all of those 30 students of your class, and your roll number is 10, right? That is, you got 81 marks. Now, to understand if you actually scored really high or really low, you're not only going to see in your close friend circle, but you want to understand how you performed related to the entire class. Were you above average or were you below average? So we'll see how this entire data set is going to work, right? So we will just dive into the presentation now. Excel is just here, although there's some things which I want you to notice here. Some students have 0 marks here because they were absent, right? And this is something that we'll be understanding why I actually added this absent, sign here in our, let's say, descriptive statistics, and why we're actually having it. This day, let's say this lecture is all about understanding the concepts that we'll be using for descriptive statistics and nothing else. So we'll just directly dive into it and let's see how it works. So if you see here, what is the first thing that you need to do when you get the data? As we have discussed in the last 5 series also for Power Query, Power Pivot, Excel, as well as Power BI, we clean the data, right? But let's try to emphasize again on the fact of why we clean the data in the first place for members who have skipped those lectures and have directly come to Python. We do it to identify the anomalies. So let's say you were 5 friends, and out of those 5 friends, four of your friends were the ones who didn't give the exam on a particular day. Now you are comparing your marks with your friends. That will actually give you no particular, let's say, insight. It is very obvious your friend scored 0 marks in that subject. They will score later. If they have a reattempt policy in your college or school, they will get it later. But for now, you cannot compare your marks with your friends and say that, okay, my friend scored 0 and I scored, let's say, 50 out of 100. I scored really well. Those are the anomalies that you need to remove in the first place. So we'll be left with the entire class and we'll remove their 4 friends which didn't give the exam in the first place. And that is why we need to understand what anomalies are. Anomalies are which will deviate your data from how it should look like, right? Absentees, if we are trying to get the average marks, absentees are an anomaly for us. We clean the data so that we can remove these invalid data points. The same example can be used here, and we ensure the accuracy. The more we'll actually move around with, let's say, if we had taken the average of your entire class with the friends scoring 0 for the 4 subjects, the average will come down. But if we are actually doing the same by considering your friends as well, by not considering your friends, the average might move to how it should be, and you will be able to get a better conclusion if you are above average or not, or if you are very close to the mean, that is average, right? So we'll move on to the next slide now. Is the calculation of average, that is mean. So mean is nothing but the average. So you had 10 marks, your friend scored 20. On average, both of you scored 15 marks. Now the friend who scored 20 is above average and your marks are below average. So that's how it's going to work with mean. For now, you can see for the 27 students that we have, that the average score is 76.74 and you scored 81 marks. So we can say we are above average. We scored really well, but we are very close to the mean. We cannot say we were exponentially good. We were just good enough, right? And then we have median. Now median is basically we need to sort the data on ascending order. So it will, for the 27 data points, it will be the least marks, then it will keep on going to the higher marks, and the central point, that is on the center, we leave some data points on the right, some data points on the left, we'll pick the center, and that would be our median, right? So if we say in our data set, median is the 14th value, because we are leaving 13 on the right, 13 on the left, that is 26, and then in the middle the 14th value is going to be our median, and our 14th value is actually 77. And okay, let's say why we have median in the first place. So we can say if you're actually having the entire dataset in ascending order, 50% of the dataset is below 77, 50% of the dataset is above 77. So we can conclude that we are in the top 50 percentile, right? So we can conclude that with median. Mode is basically the number of times a particular data point was actually repeated. So let's say there are 5 friends, 2 of the friends scored 10, others scored 20, the fourth one scored 21, and the fifth one scored, let's say, 50. Now all of these data points, 10 is actually repeated, and that's the mode, the value which is occurring the most. So we can do it just how we actually did for our last lecture also. We were able to using value counts, we were able to see how many times a transaction was happening in a particular coffee type, right? That's exactly what we want to know in our descriptive statistics also. What is that one number which is being repeated again and again, and what is the one number which is being repeated the most, right? That would be given by mode. And then from descriptive statistics we go to something as variability measures. Now if you will read all of these definitions, you will be able to get a proper understanding of what this is exactly. But variance and standard deviation are somewhat similar. So range is the lowest point to the highest point. So in the example that we just we took with 5 students, the range will be from 10 to 50, right? Variance is how much is the deviation that we are seeing in all of these data sets, right? And standard deviation is nothing but the square of variance. You can see the square root of variance providing measure of spread in the same units as the, and we have the variance measure how far a set of numbers are spread out from the mean. So all of these 5 friends are actually going to have a mean, and how far they are from this mean value is what variance is going to tell us. We'll see how all of these are going to work in our Excel. So exploring data distribution. So this is something about how bell curves work. So if you will go over the internet and you will be able to see what exactly do I mean by bell curves. Just search for normal distribution and skewed data. So just look how my mouse is moving right now. So imagine this to be an axis right here, right? And okay, next slide please. Okay. And imagine a bell in between, in a very the tip is actually in the middle. So whenever the bell's tip is actually in the middle, we call it normal distribution. So the center is always the mean, as we always saw. We have an axis here, the center is always the mean. So we say the most number of data points are at the mean. It's the frequency. That is a normal distribution. But whenever this shifts towards some other data point, that is, let's say whenever the highest number of data points are on something which is something else than mean, any other data point, then we call it skewed data. When it is above average, then we tell that we are having a right skewed data. But whenever it is below average, we say it is left skewed data for us, because the bell will move towards the left. We are increasing average, increasing numbers are here, and in between we have average. We have bell curve here. Whenever it will be above average, the bell curve will be on the right, so it will right skewed, and whenever it will be on the left, it will be left skewed, right? This is important for you to know just right now itself. And when do we use mean, median and mode? Whenever we have normal distribution in the middle, mean, median and mode are going to be the same. What is mode? Mode is nothing but the highest frequency, right? and median is the central value, and average is the middle. Is the mean is the average, median is the middle value, and whenever we have a bell curve, everything is in the middle, right? That's why mean median mode is actually going to be the same. Although for skewed distribution, that's not going to be the case. For skewed distribution, we'll actually have median as a measure. So the tip point will be more, in center we'll have mean, in between both we have median, and whenever we want to get, let's say, the central tendency, we need to understand median whenever data is skewed. So before we get mean median mode ever in our data analytics, that is descriptive statistics, we first see how the data set is being distributed, right? If the data set is actually skewed, we always go with the measure of mean, and if it is normal distributed, we can use anything, right? So median is the key that we want to use every single time. That will give us the middle value, because median is something that will work with skewed data also, as well as normal distribution, because median is same as mean as mode, right? So we'll work around with mean whenever we'll start working. And descriptive statistics is across a lot of fields, but majorly we just saw an example of how it is being used in education. Majorly it is also used in business, because we might want to know what is the average transaction value, something which we were doing in our last on our first case study in Python, that is index.csv. And it is also done in healthcare to understand, let's say a person is having high blood pressure, so how many times a person in a particular day is having high blood pressure, that is the mode, right? What is the highest blood pressure the person is having? What is the average blood pressure the person is having in the entire day? So it is also used in healthcare majorly, like all the time, every day. Although we have the examples from all across the fields where we can apply descriptive statistics. So this lecture will end here, and I would like you to actually go around and to search over the internet how we can work around with all of that. I hope these lectures not getting confusing for you, because I've seen students getting confused, but once they actually go through the entire lecture again, or let's say pause it, understand it, and let's say and not skim through the entire lecture, and they absorb all the information being taught to them in this entire series, they are able to do way better, right? So I hope you are able to just absorb all the information, not just skim through it. I hope you are making notes as discussed in my first lecture as well. That would be it from my end. In the next lecture, we'll start working on all of these examples, right? As in Python. So we'll understand how mean, median, mode. It's not like we'll not learn how to do mean, median, mode, and we'll just learn about median. We'll learn about all of them in our Python series. So that would be it. I'll see you on day 6.